Alrighty, folks. Hello. So, this is going to be our first lesson of the year. We're going to start off with talking about the different parts of an algebraic expression, right? I will say right off the bat that I'm using a bit of new software and hardware to record this, so if things are a little weird, bear with me. We're going to get through it. So, we got different parts of an algebraic expression. So, we've got this algebraic expression down here, right? This 5x plus 2, right? And all of these different pieces have different names that we're going to use throughout our class. So this 5 that's up front here is called a coefficient. A coefficient is just a number that's coming before a variable, right? So you'll see like 5x, 3y, 74z, 45a, and whatever else. And what's really going on there is that it's kind of like it's hiding some multiplication, right? So in this problem, or in this expression rather, we have 5x. That is the same exact thing as 5 times x, right? It's telling me that there's this thing called x. I have 5 of that thing, right? Or it's x times 5 of it. The x is a variable, right? You've run into variables in the past. The really simple definition is it's just a letter or a symbol, right? You could use triangle if you wanted to. And we use that to represent a quantity that we don't know, or sometimes one that changes, right? So in this case, we don't know what x is. Sometimes we might not ever find out, right? The problem might just be to simplify it in a different way, right? But once we figure out what x is in some problems, we can then plug it back in and do sorts of other things. We've also got a plus sign here, which is an operation, right? Or sometimes called an operator. It's just a symbol that tells you what to do with your terms, right? And I know that it mentions this word terms. We're going to get to that in just a quick second. So the different operations that you might run into are obviously plus. You could have a minus. You could have a multiply, or you could have a divide, right? When we're talking about multiplication in particular, right, you could use that little star thing. You might have noticed that over on the left side of the screen right now, I used a dot to talk about multiplication, right? I would suggest not using an x to represent multiplication anymore, right? Don't do that one. Right, because x is now a variable, right? So you're going to need to know when it's a variable and when it's multiplication. So I'd use either that star, like the asterisk, or just a dot. Right? Sometimes you might even, like when we see with coefficients, you might just have your multiplication be that they're just next to each other for things like coefficients and variables. We've also got a constant. Whoops, I just accidentally threw my stylus. We've got a constant, which is just a number that's all by itself, right? So if you want to think about it this way, right, we talked about how x can sometimes just change, right? We don't know how much it is. So 5x altogether might be a different quantity, right? The 2, it's a constant. It's going to stay constant at 2, right? It's not changing. You can make x 14 billion, and that 2 is still just 2, right? So when we talk about terms, right? So a term is just a big chunky piece, right? So a little bit further down here, right down at the bottom of your screen right now, a term is a piece of an expression separated by an operation, right? So you notice that I have these two terms, and then there's this operation in between them that's separating them. You can kind of think of them as the big chunky pieces of expressions. And when we're talking about an expression at all, right, its full name is an algebraic expression. It's sort of like a math sentence fragment, if you remember what you've learned in English in the past, made of numbers, variables, and operations, right? So let's just jump right in, right? I've got this expression here, right? And just to quickly go back through and identify what the different parts are, if you want to pause for a second and think about which ones of these are coefficients. All right. So hopefully you paused and took a look and said, all right, I think it's these. Right? I'm going to tell you that the coefficients here are 2, 10, and 84. Right? Because those are all the things that come in front of a variable. Right? 15 doesn't count as a coefficient because it doesn't have a variable near it. Right? All right, maybe take another second, pause again, and think about which ones are the operators or operations. All right, and hopefully you came up with these 3. We've got division, we've got addition, and we've got some multiplication there. Right? These operators are the chunks that separate those different pieces of our expression. All right, something a little bit different. Let's talk about the terms, right? So again, pause for a sec. Think about what the terms might be. Right. The terms here are 2x, 15, 10y, and 84z. Right? Those are the terms because they are just like the chunks, right? That's a chunk, and then we have an operator. 15 is its own chunk, and then an operator. 10y, a chunk with an operator next to it, and then 84z on the end. All right, so that's how we can tell what the terms are. They're just the big chunky pieces separated by those operators. All right. So the real meat and potatoes of what we're going to do today is talk about order of operations, right? So we've talked about how an expression is like a math sentence. The important part about it is also that it doesn't have an equal sign, right? If you have an equal sign and something on the other side, all of a sudden we're talking about an equation, not an expression, right? It's not going to be super duper important to be able to tell like, oh, this one is of course an expression, right? But just something to know. And then we're talking about evaluating. It's kind of like solving an expression, getting it down to just a single number answer, right? So that's really what we're trying to do here is we're just trying to simplify these things so that they just come out as a number, right? So we're going to review some sign laws real quick. Let me zoom in a bit. So you might run into something like 3 plus -4, right? So just something quick to review is that when you're adding numbers like this and one of them happens to be negative, you can kind of shortcut it a little bit, right? So instead of 3 plus -4, that's the same thing as just doing 3 minus 4. All right. If you've got something like 3 minus -4 like that, right, we can do something sort of similar, right? What I like to think about it is if I've got a double negative, it's like when somebody says that you can't not do something, it means that you really have to do it, right? So these double negatives kind of cancel each other out. What I like to think about is that they just kind of turn into one big old plus sign, right? So if we were rewriting that, we could make it look like 3 plus 4. All right. Another sign law that we might run into, something, we already know that 3 times 4 is just, multiplication, right? That's going to give us 12. What I find is that a lot of people get a little tripped up when there's some negatives involved, like -3 times a +4, right? So if you have a negative times a positive, your answer will be negative, right? On the other hand, if you have a -3 times a -4, right, they're both negative, your answer will flip back to positive, right? So what we can kind of see is that it kind of sort of goes with what we were doing up top, right? If you have a double negative, kind of like this down here with 2 negatives in it, they sort of cancel each other out a bit, right? If you've just got one hanging around, it sticks around, right? So negatives can cancel each other out just like that. Right? We have a couple other properties that we should talk about before jumping in. We've got this thing called the associative property, right? And the way that I like to think about these ones, and the way that helps me remember, is think about what these different words mean. Associative. You've heard of like associates. It's just like a group of people that you kind of hang out with, right? So the associative property in this case means that if I have 3 plus 4 plus 5, right? That's the same thing as saying 3 plus 4 plus 5. Right, so you can see that those parentheses kind of shifted, right? Instead of grouping the 3 and the 4 together, they instead grouped the 4 and the 5. But those come out to be the same, right? No matter how I do that, that should still come out to be 12. Right? So with addition, you can do the associative property. You can just like group them however you want. You can also do the same thing for multiplication, right? If I had 2 times 5 times 3, I can instead group it this way, 2 times with the 5 times 3 in the parentheses, right? Those will come out to be the same thing, right? And in this case, that's going to be 30, right? The commutative property is something that's sort of similar, right? It talks about like different ways that we can write things that actually come out the same. So commutative Makes me think of like, all right, you got people with morning commutes, they're driving to work. So it's kind of like you're going from one place to another, right? You're swapping places, right? So this one should hopefully make a lot of sense, right? 3 plus 4 is the same thing as 4 plus 3 all the time, right? They're both going to come out to be 7. There's nothing really fancy with this one. Same thing goes for multiplying, right? If I do 3 times 4, it's the same thing as 4 times 3. All right, so with the associative and commutative properties, it's just another way of showing, things that can be the same no matter what way you order them. All right, let's talk about the order of operations, the whole big thing here. All right, so you might have heard about this in the past, and you might have heard it referred to as PEMDAS. All right, so PEMDAS, PEMDAS. All right, so the P stands for parentheses, right? So you might have parentheses that look normal like that. You might have these like square parentheses, or you might have these braces as parentheses, right? So if things are kind of grouped that way, that's what you're going to start off by doing. You want to take care of the stuff that's inside that group. The E stands for exponents. Right? When we're talking about exponents, we're thinking about like, oh, if I have 3 squared, or if I have 2 to the 5th, right? I want to take care of those exponents and simplify those before I then keep moving along. Right? These next two kind of go together, right? The M and the D, right? M is for multiplication. Oops. Except if I can remember how to spell multiplication. So we got multiplication and we've got division, right? So again, we talked a little bit about what multiplication can look like. You can either have the little star or you might have a dot. For division, you might have that symbol there that you know to be division. You might just have a slash, or you might have something that looks sort of like this, right? Which is a fraction. Don't forget, fractions are just division. Right, and the reason that I was saying that these kind of go together, right, is because you're going to kind of take them as one step, and you're going to do them in whatever order you run into, going from left to right. All right, so if you're, reading through your expression from left to right and you have some division and then some multiplication later on, do the thing that comes first, right? The division you ran into first, take care of that, then do the multiplication later. All right. Same thing is going to kind of go for these last two down here. A is for addition, and S is for subtraction. All right. So addition, just got the plus sign, subtraction, just the minus sign. All right. But again, same kind of idea. It's one step. You're doing it whatever you run into first from left to right. All right, so there is a helpful phrase that can help you remember the order of this, right? You can just remember PEMDAS, right? There's nothing wrong with just PEMDAS, right? You can just write it down on the top of your paper when we're doing stuff with this and just kind of run through it that way. But I like to use the phrase, pomegranates encapsulate Martha's dinky acidic sheep. Just kidding. That's not really the one that people like to use. The one that people really like is, please excuse my dear Aunt Sally. Oh, Aunt Sally. She's such a joker. All right. So I like pomegranates encapsulate Martha's dinky acidic sheep, but please excuse my dear Aunt Sally kind of rolls off the tongue a little better. So whichever one you like. All right, let's actually get into it. So again, thinking PEMDAS, we're going to evaluate some expressions using the order of operations. All right, so what I'm looking at here is I'm noticing, all right, I've got some parentheses here, right? I've got this whole chunk that's in parentheses. I'm going to start off by taking care of what's inside there. When I jump inside some parentheses, I then want to restart the timer in my head. I then need to think, all right, are there parentheses inside these parentheses? Thankfully, no. Right? But after that, what I'm running into is that I have an exponent there that I need to take care of. All right, so what I'm going to do first is I'm just going to bring everything else down, right? We got 9 plus 30 minus, and then 3 squared, 3 times 3, is 9. All right, so that's what we've got there. Actually, I'm going to make the pen a little smaller. I'll see if that works. So I'm still working inside these parentheses here, right? I just now need to go forward with the steps, right? We did exponents. All I've got left in this set of parentheses that we're working in is just addition and subtraction. So I'm going to do the 9 plus 30 gives me 39. Right, so that's 39 minus 9 in the parentheses now. Again, bringing everything else down. I haven't even touched that second half yet, right? We're not there yet. And then I'm going to do 39 minus 9 is just going to give me 30. Right? When you get down to just one thing, you can drop the parentheses, right? We don't need them anymore, right? Because the group is just one thing, right? If you're feeling like you're up to it, right, we can kind of shortcut this last piece too, right? 17 minus 7 will take care of those parentheses. That's just going to come out to be 10. All right. At the end of all this, 30 divided by 10 is just 3. Right? So using the order of operations really wasn't too bad, I hope, right? We started off, we took care of exponents, right? We started off by saying like, all right, we got some parentheses. We did our exponents, and then we did some addition and subtraction, and then we did our division once we got out of the parentheses, right? You might be thinking to yourself like, well, why did we do addition and subtraction before division, right? It's because that addition and subtraction was inside some parentheses, right? So it needed to be taken care of first, right? After we pop out of the parentheses, then we can kind of keep going as normal. All right, let's try another one. Oh, this one looks like a doozy. All right, so what we've got here is we've got 11 minus 2 in parentheses squared plus 14 minus 15 divided by 3 in some other parentheses. So again, same idea. I've got some parentheses looking me in the face right here. I need to take care of those first. All right, so inside the parentheses, 11 minus 2 is just 9. Right? And again, I don't need the parentheses anymore, so we'll pop that squared on there. Right? The other set of parentheses, nothing's changed yet. So we took care of that first set of parentheses. We've still got more parentheses over here to worry about. All right, so now we're going to move on to working inside of those ones. I'm going to bring that 9 squared down, add a little plus sign, and then let's take a look inside those. I have 14 minus 15 divided by 3. All right, so if you haven't yet, take a quick second, pause this, think about which one of those would I do first, 14 minus 15 or 15 divided by 3? Hopefully you said 15 divided by 3, right? Because while I'm in there, I'm still going in PEMDAS. Right? So division comes before subtraction. Right? So we're going to take care of that first. Oops, switch back to that. So this 15 divided by 3 is where I'm going to focus my efforts for right now. I have 14, and then it's minus 15 divided by 3 is just 5. After that, we're still inside those parentheses, right? While I'm in those parentheses, I need to go ahead and, take care of the subtraction that's left over. This is still 9 squared. 14 minus 5 is going to give me 9. All right, cool. All the parentheses are gone. We're free of those. Now I have to go back. We did parentheses, and then everything inside here was inside parentheses. Right, so we need to keep on going. We have to take care of any exponents that are hanging around. So in this case, 9 squared, 9 times 9 gives me 81. And then the only thing left to do is to add those together, which will give us 90. All right. Hopefully this doesn't seem so bad. All right, take it one step at a time and go from there. Ew, 3 different chunks of stuff. Why would I do this to you? Right? But this one's actually not too bad either, right? Let's take it one step at a time. We've got some parentheses. We need to take care of the stuff inside those. All right, so this first set of parentheses, 10 plus 6, well, that's just 16. Again, if you're feeling up to it, we can kind of shortcut this a little bit, do a little bit less writing. 8 minus 5 in that other set of parentheses is just going to be 3. All right. Don't forget to bring everything else down just as it is above. All right, so we've still got 16 times 3 minus 9 squared. All right, let's clean that 9 up a little bit. There we go. So we did parentheses. Now we're moving on to e for exponents. So we're going to take care of that 9 squared. This is 16 times 3, and 9 squared, we know from the last problem, is 81. While I'm going through these, or while you're doing them, some of them on your own as well, it's perfectly okay to use a calculator, right? If you want to type in 9 squared, go for it, right? I'm not going to judge. Right? From here on out, right, we took care of parentheses, we took care of exponents. Now we're on to multiplication and division. So 16 times 3 is what we're going to do with that. 16 times 3 is going to give me 48. Again, bringing down everything else just as it was. Last but not least, I have some subtraction to do. 48 minus 81 is going to bring me down into the negatives. That's going to give me negative 33. Right? One way that I like to think about, am I going to end up with a positive number or a negative number from this, right? Is imagine, that you were in a really tall building that also had a really deep basement, right? So ground level right there is 0, right? You've got all these floors in the building all the way up. Those are windows if you couldn't tell. And this is a door. All right, cool. And then they've got a really deep basement with multiple floors there, right? These are different rooms, I guess, right? So ground level is 0. You're in an elevator. If you're up at the 48th floor and then you're going down 81, you're going to end up in the basement somewhere, right? So down 81, it's going to bring you down to the 33rd floor below, so it's like negative 33. Right? That's the way that I like to kind of think about negatives in a way that makes sense, right? If I can imagine a number line that goes up and down like that. All right, that's really what we're doing here. Right? So if you haven't yet, try pausing here. Try this one out, right? Think about it one step at a time, and if you get it wrong, it's not a big deal, right? We're going to go through it again in just a quick sec. All right, so pause here, give it a shot, unpause when you're ready. All right, so in this one, I've got some parentheses here, right? I need to take care of the stuff in those parentheses before I go any further. All right, so I'm going to bring down 5, bring down that multiplication sign, and then inside those parentheses, I got to think about where to start. I could do 7 times 7. I could do 7 plus 9. But what I think I might want to start off with is taking care of that 9 squared, right? Exponents come before all that other stuff. So what I'm going to do is I'm going to bring 7 times 7, that plus sign, and then that 9 squared is now going to turn into 81. Actually, let me try doing a little bit of color coding here. Maybe that'll be nice. All right, so we just changed that piece. We're still working in those parentheses because there's still more to do in there. Right, let me zoom in a little further. So while we're still in there, right, I now have some multiplication and I have some addition. I'm going to start with the multiplication. Right, while I'm doing that, again, everything else on the outside still hasn't changed. We're going to keep it the same. That 7 times 7 is going to give me 49. We've got that plus 81 still hanging out, and then that minus 10 on the end. All right. Oy, this number is not going to be very nice, but that's okay. So here we've got 5 times. We're going to finish off the parentheses, right? Because there's only one last thing to do. 49 plus 81. It's going to be what, 130? All right. And then we've only got 2 things left to do, right? We've got some multiplication over on the left. We've got some subtraction on the right. I'm going to do the multiplication first because that comes before subtraction. So 5 times 130 is going to give me 650. I'll bring along that minus 10. And then you just chop 10 off of it, right? We're subtracting that 10 and then we're going to be done. Our answer is 640. All right. So as you might notice, I started to run a little short on space, right? when you're doing these on your own, right, if you ran out of space after this step, just draw a line over and then do your next step, right? If you want to even just rewrite exactly what we had here when you're moving it over, perfectly fine, right? Whatever helps you organize your work the best, right? All right, let's take a look at another few, and then we'll call it there, right? So same kind of deal here, right? I'm going to go through this on a little on the quicker side because it's pretty similar to what we just did. Got these two sets of parentheses that I'm going to take care of. 21 plus 8 is 29. 12 plus 6 is 18. Bring everything else down just as it was. All right? Now what I've got is I've got this squared here, right? I want to take care of that exponent. All right, so that 29 times 18 stays the same. 6 squared, 6 times 6 is 36. Now all I'm left with is just some multiplication and some subtraction, right? Multiplication comes first, right? So 29 times 18. Oh boy, howdy. I'm gonna have to break out my calculator for that one. 29 times 18 is gonna give us 522. All right, minus 36. All right, so taking care of that subtraction is our last step. 522 minus 36 is going to give us 486. Wabam, we done. All right, how about let's take a look at one more. Let's skip down to 7, right? I'll leave number 6 as one for you guys to try out on your own. It will be in the notes that I'm going to upload to our Google Classroom, so if you want to check your answer and check your process, be sure to check in there. If you're still not sure on where to go to find that, let me know. Send me an email real quick or ask me when you see me during class, and I'll kind of fill you in on how to get to that. All right, but try 6 on your own. We're going to talk about 7, and then I'm going to stop talking here. Oy, oy, oy. So the reason I wanted to talk about this one in particular is that it's a little tricky. Right, you might notice that we have some parentheses staring us right in the face at the start, but there's just one thing in them, right? There's a -1 and there's a -7. So the reason that these are in parentheses, even though they're by themselves, is because we want to make sure that that negative is captured with it, right? So that -1 is not just -1, right? It is itself -1. Same thing with the -7. Right? So what that's going to allow us to do is when we eventually move to multiplying, we know that we just multiplied -1 times -7. Right? But we actually have some other parentheses here that have some other things going on first. We have 3 plus 2 that we can take care of. All right, so bring everything else down. And not touching anything other than that bit that's in those parentheses underlined in red. 3 plus 2 is going to give us 5. And we got that -5 squared hanging on the end. All right, now we did our parentheses. Right, again, these bits of parentheses up in the front are fine as they are. Right, it's just to kind of make sure we keep the negative with them. We don't actually have anything to do with those. So we're done with parentheses. What we now move on to are exponents. Right, so this 5 squared needs to go. So again, bring everything else down. Plus 2 times 5 minus, and then 5 squared is 5 times 5, gives us 25. Okay. Oh man, we're sort of getting there. All right, so parentheses are done, exponents are done. Next up is multiplication and division, right? Whichever one we run into first, left to right. So I do have 2 bits of multiplication to do here, but this one is first, right? We're reading it from left to right. So -1 times -7, when we multiply those, we're going to end up with a +7, right? Again, bringing everything else down all the same, right? Then we'll take care of our other multiplication, 2 times 5. 2 times 5 is just going to give us 10. Oops. All right, and then -25 on the end there. Cool, so our multiplication and division is done, right? Because we don't have any of that left. Now we're on to addition and subtraction, again, moving from left to right. So moving from left to right, we got 7 plus 10, which is 17, minus 25. And then this subtraction is going to finish us off. 17 minus 25 is going to give us negative 8. All right, again, if negatives seem a little bit hairy to you, right, think about, you're on the 17th floor of a building and you're going to go down 25 floors. You're going to end up in like the 8th basement, right? 8 floors down into the basements. All right. So I hope that this went pretty okay, right? If you have anything on your paper at all, make sure you have PEMDAS. All right. So be sure to check on Google Classroom for any additional stuff that I might need to have you do. Make sure that your notes are all good and everything is peachy keen. And I will see you soon. Bye.